All right, guys, we continue to question 30. Now we talk about a regression. The table models distance the car with a locked brakes skids while coming to a complete stop after traveling at a certain speed. Now it says determine quadratic regression. So right there, it tells you it's a quadratic regression and find the equation. So we're going to go to Desmos. All right. And you're going to put the table in. You're going to press plus and then the table and then plug in the values you are given. Now, this is your x1 and this is your y1. So when you're writing a regression equation for quadratic, it's going to be y1 because you are referring to your table. And of course, here to get dots, you just hold this and then get a line for you to be able to see what it will look like. The values are big, so make sure that you scroll out. So I know it kind of looks like a linear, but it's not. It's just a part of the quadratic function. It will continue going. So you're going to be able to see it in a minute. So y1 and then a squiggly. And the equation standard form is ax squared. And of course, you're going to put a 1 there to relate to a table. Plus bx1 to relate to a table plus c. Okay, so like as you see, follow the dots. It is a quadratic equation. Now, here are your values that you're looking for, your A, your B, and your C, okay? So when you're writing this equation for the regression for the quadratic, you're going to use it, okay? So let's go back to the table. And so the equation standard form, of course, it's ax squared plus bx plus c. So we're going to plug in our A, our B, and our C in the right spot. So for A, we had, now I'm just going to round it up to like a 2, let's just say 3 decimals after. So 0.42. Oops, 0, sorry about that. 0.042 x squared. For our B, we had 0.049, so I can do 50. X to round it up and then minus negative, the C was negative 3.651. Okay, so that is your regression quadratic equation. Again, how do I kind of know if it's a quadratic? Another way to look at it is checking your R square right here. And closer to 1 it is, the more true of the equation it is. So as a quadratic, it's 0.99, so that is true. Okay. Now, here it says use the regression equation to predict the distance skidded if a car was traveling 73 miles an hour. So what we're going to do is we're going to take the 73 and we're going to plug it back in instead of the x's, okay? So I'm going to have 0.042 times 73, don't forget to square it, plus 0.050 times 73 minus 3.651. Now, again, when I put it all into the calculator, I should get 233. I can also, so I should get 233, 233. I can also go in here and calculator, or you can go and check it out right here on the graph. So remember, 73 represents x-axis, okay? So you can try to best your ability. There you go, okay? So that's 73. It's 223.27. So if I want to round it up to a whole number, it would be 223. So at 73, again, as your x value, that's what it would be, 233. So, and you can put it also in the calculator, okay? So that's 233 feet, okay, as a distance, because feet indicates right here, all right? All right, next question. 31, data shows the number of visitors at a state park between 2006 and 2011. Use the technology to create a scatter plot and determine the regression equation for the data. So again, I went on and got it into my Desmos. This is the data right here. We got to figure out if it's a quadratic or cubic. So if I look at this and I make these lines right here, we got to make it bigger. So let me make this bigger. So it does look more, it does not look like a quadratic because it goes a little bit to the right. So it looks more like a cubic. So let's try it. So the equation will be y1 for cubic. And then remember, you start with ax cubed, okay, and then 1 because you're referring to your table, plus bx squared, and then 1 because you're referring to your table, plus cx1 of 1, and then plus d. Okay, so again, to make sure, we got to check it is closer to 1 for our square. So that means that it is truly to be cubic. Now, as you can see on a graph, it also happens. And now these are your A's, these are your B's, and these are your C's, and this is your D. Okay, so we're going to take it back to the slide and plug it in. So it is a cubic equation. So what I'm going to do is I'm going to plug, and instead of ax cubed plus bx squared plus c x plus d, I'm going to plug in all the values that I was given. Okay, so the values that I was given were, and I'm going to round it up to like 0.103. Okay, x cubed minus 1.21. 5x squared. My c was positive 3.791 x, and my d was 1.7095. Okay. Now, the second part is asking us use the regression equation to predict the number of visitors in 2012. So remember that here it's listed a number of visitors since 2006. So what does that mean? That means 2006 was at 0, 2007 was at 1, 2008 was at 2, 2009 was at 3, and so on. So 2011 ended at 5, so 2012 would be at 6, okay? The other way to do it is 2012 minus 2006, okay? Which is going to be 6 as well. So what we're going to do is we're going to plug the 6 into our x cubed, okay? So again, 0.103 times 6 cubed. Don't forget to cube it and square it. Times 1.215, 6 squared, plus 3.791 times 6, plus 1.7095, okay? And again, what you should get the total of, it's 2.9, which you could round it up to 3 tenths of 1,000 visitors, okay? All right. Visitors. Okay. You can also go to Desmos again and look for that 6. All right. So 6 value would be somewhere here. There you go. Okay. So it's 6 as your X. It's 2.9 for your Y, which is 1,000, which is visitors, tens of thousands of visitors. Okay. All right. Next slide. All right, again, another regression. For this one, it is a cubic function. I'm going to show you how I know that. Again, I took it and I plugged it in. And then hold this button to get some lines. And of course, these are big numbers, so I am going to zoom it out to see it. I know it kind of looks like it could be a linear, but it should be a cubic. So let me see if I put a cubic, what is closer to our R square regression. So it's going to be ax cubed 1 plus bx squared 1 plus cx1 1 plus d. Okay, so there you go. It shows really nicely, and it's at 0.98, so very close to the 1. So again, that looks very nice, like a cubic function, if you're looking at it this way, okay? So now, again, we don't have to do the numbers. Up here, it's simply just asking us if it's cubic or not, okay? So it is a cubic function. All right, moving on to number 33. It says, what are the numbers of possible solutions for a system of linear and quadratic? So again, it is the quadratic, it's a parabola. So if it was like right here, you have 3 different options for linear. It can just completely miss it, which is 0 solutions where they do not cross each other. You could have one where the function is touching a quadratic equation at one spot, so like right here, that would consider it a one possible solution. Or you could have a linear equation that will cross a completely, where you will have two different solutions where the quadratic and linear crosses in two places. All right, 34, what are the solution of the system of the equations? Again, solution is where the functions cross each other. So in these two spots, not x-intercepts, in these two spots where the 2 points are, that's where the two functions, the quadratic and linear, cross each other. So here the point is 0 for x and 3 for y, and here the point is 4 for x and -1 looks like for y. So again, the answer would be C. All right, determine the solutions for each system of equations. Again, for this question right here, what you can do is you can graph both of them to save time, but if you would have to solve it by hand, you would equal them to each other. So I'm going to do number 35 as you would solve it. So 2x squared minus x plus 3 now equals to x squared plus 5x minus 6. Of course, I'm going to move this side to the other side to combine like terms, okay? To zero it out on the right, all right? Now, this is going to be x squared, this is going to be -6x, and this is going to be +9. Now, I'm going to do a times c, okay? To find two factors to multiply to 9 but add to 3, it's x minus 3 and x minus 3. I equal them to 0. They're the same factors, so x will equal +3. Now, I have to take this 3 and plug it back into one of the equations. So I'm going to plug it into x squared plus 5x minus 6. So instead of the x, I'm going to plug in the 3. So it's 3 squared plus 5 times 3 minus 6 equals 18. So my point, this is my y, okay? So my point right here is 3 for x and 18 for y. That's my solution, okay, for this equation. Now I'm going to take it back to Desmos to confirm it. Again, I took it. I'll put both equations in here. I'm going to zoom it out, and I'm going to see where do they cross. They cross somewhere here. It's going to pop for you. There you go, 3 and 18. So 3 for x, 18 for y, okay? Very good. All right, and then this function right here, 36, I'm going to simply graph it. I'm not going to solve it by hand to save time. So again, if I plug it in right here for you, this function obviously crosses in two spots, which is here and here. These are my both solutions. You can't just write one point out. You have to have both. So this is going to be -6, okay, and -4. And the second point of the solution is -4 and -4, okay? And then if you would solve it, you will equal them to each other and get the same answers, okay? And you have to make sure you plug it in both to get two y's, okay? All right, this question, 37, the revenue for company producing electronic components is given by an equation, okay, where X is the price in the dollars of each component. The cost for the production is given with this equation. So you got two equations, determine the price that will allow. Again, if you want to equal them to each other and solve for X, absolutely, and for Y, I am going to save time to help you, and I will graph it. You graph both. This is a linear equation. This is a quadratic equation. Again, you're going to make it smaller to see where do they cross. Also remember, you only concentrating on positive quadrant, okay? You cannot have price in dollars and a cost or revenue in negatives. So you wanna make sure you're in a positive quadrant. So again, I'm going to zoom it out. So make sure you guys zooming it out on your Desmos in practice. So they cross at 1.5 and 80. So that's my point of this, the solution to this equation is 1.5 and 80. And so now our question is asking determine the price with that will allow the company to break even. Price stands for X. So this would be $1.50. Okay, would be my price. All right, the next question, 38, describe number of zeros. So remember, the degree matches the zeros. So if this is in a descending order in a standard form from the highest degree to the lowest degree, I am expecting if I have a degree of 5, that means I have 5 zeros, okay? Now, what else can I tell? It says an end behavior. So what else can I tell about this function by just looking at it? Well, I'm going to start with the leading coefficient and the number in the front. So I know that this is the leading coefficient and the exponent. So I know that this is an odd function, okay, which means that the ends will go in opposite direction, okay? I also know that it has a negative leading coefficient, which means, let me erase that, the tail will go down, okay? So it will go like this in two different directions. So two different direction is an odd, and the end right tail goes down. So that means that if I'm talking about the behavior, that means on a positive side, right? If this is a function on the positive infinity, okay, let's just say this is a function, okay? On the positive side, I know by leading coefficient that my end, my function, will be going down, okay? I also know that this is an odd function, so that means on the negative side of the graph, my function must go up. These two have to be the opposite. Okay. Now again, I would highly recommend to graph it to confirm your theory. So again, if you're looking it down, you can see that right end goes down as a leading coefficient. The other end goes up. On the right side here, our function goes down. On the left side, our function travels up. Okay. All right. Next question. Identify whether the function degree is odd or even, positive or negative. So again, odd means ends go in the opposite direction. Even means they're going in the same direction, like this, okay? This is definitely an odd function. So I can already cross out and eliminate some of my answers. So even would not be a case. Now, positive, negative depends on your tail. Your tail is going up, not down. So that means it will be positive, okay? All right. This list of zeros, which zeros with their multiplicity of the polynomial. So again, zeros are how many factors do I have here? So I have 1, 2, 3 right here. So let's equal them to 0 to see what are my zeros. So I'm going to take all of these and equal them to 0. All right, so I got 3 equals 0. Well, let's start right here on the beginning. All right, so I got 3 equals 0, which is not true. I got x plus 5 that equals 0. Okay. And of course, you have x plus 2 equals 0. You got x minus 1 equals 0. And you got x minus 5 equals 0. So I took all these factors and equal them to 0. Okay. Now, all you're doing is solving for x. So this is just flipping the sign. X equals 5. X equals negative 2. X equals 1. And x equals 5. Now, the multiplicities are going to be these little exponents right here. Okay. So obviously, the multiplicity for negative 5, it's 3. The multiplicity right here for negative 2, it's 4. The multiplicity for 1, it's 2. And the multiplicity for 5, it's 1, because there is nothing there, and it's assumed as 1, okay? So again, you know, this will be a slide, this will be a bounce, even though it's 4, it's an even. This will be a bounce, and this will be a slide. So again, you can go back here if you don't remember it, and you can graph it, okay? So when you're graphing this in Desmos, okay, you're going to be able to see it. So again, this at 5, it said it was a slice. This, I know it doesn't look like it, but you got to zoom it in if you can't see it. It is a bounce. It touches, it comes back up. Bounce does not cross x-axis, right? So again, you can see right here, very small, how it's bouncing up, okay? The same thing right here, if you go back. Let me hit home very quick. This one looks like a bounce. This one looks like a slice, but it's not. Again, when you get closer to it, you can see it's sliding, okay? So it goes down, slides on the top, and then it goes down, right? So it comes down, slides, so it's not slicing, so that's 3. So again, use Desmos for your advantage, okay? All right. 41, given the following graph, find which one is degree. Again, whatever number is here it will be the opposite. If this equals 4, the factor will be x minus 4. Okay, it does look like a bounce. It touches and going, so it has to be a 2. Okay, this one definitely looks like a slide. So if you have x equals 1, in a factor, it's going to be the opposite because you're equaling it to 0. And then a slide, it's 3. And then right here at this point right here, looks like a bounce, and it looks like it's at 0. So again, if this is a tricky one. If you're moving 0 to the other side, you're going to have x minus 0 equals 0, okay? Technically. Now, again, we don't put 0 there, so it's really x equals 0. Now, you know if you're putting it into a factor form, it's going to more look like this, okay? And then since it's a bounce, it will be a 2. So this really is x squared. So I can tell it's not a cube. It's not a cube right away because at 0, I don't have a slide. I have a bounce. Now I got to compare my two other factors, x minus 1 and x minus 4, to be a c. Okay, so always remember whatever number is here, it's going to be the opposite in the factor form. All right, and then the last one for this video, 42, which characters describes the graph? So you can just eliminate a bunch of them. So first one says leading coefficient is positive. Let's check. Is it going up? That is correct. And this is an even function. Does it have ends going in the same direction? No. This is an odd function, okay? Let's do D. The leading coefficient's negative. That's already not true because, again, we already eliminated it. So, and it is an odd function, so, but it is not leading coefficient that is negative. It is positive. It goes up. Now, B states when the x values approach positive infinity. That just means when x values are on the positive side, my y, which means my tail, is going down. This is not true. My tail goes up, okay? So the last one must be true. Let's check it. We got x values approaches negative infinity. My function traveling down. This is correct, okay? So the correct answer for this one would be C.